Hello, student. So today we will get to know about the electric charge. So before that, let's understand what is electric charge by their definition. This is basically coming from the chapter. We have 12 class chapter, that is electrostatic, and charge is one of the topic of this chapter. So what is that means electro? Electro means we have charge, and static means in simple you can say rest. Here basically in electrostatic discuss about the effect of charge on rest. So first you have to remember this thing, means we are going to study in electrostatic the charge at rest. Now what is the objective of this? Okay, so in this lecture we get to know everything to understand about the electric charge and transfer by friction. Basically we have three mode of transfer of charge. One we have by friction, and other two we can say one is other two, this one is second one we have is by induction, and third process we have that is the simple one by conduction, and the friction is also one of them. Okay, so let's now come to the this subdomain. Like we have electricity, right, in our household. You know that in household there is an electricity following through the wire. We have lots of wires, and also the electric equipment are there. Like we have bulb, we have fan, selling fan, we have motor, and we could have many other things as well, like laptop or some PC. So basically here the electricity is what we divided it into two parts. Majorly the current electricity, that means when the charge is flowing, when charge is flow, that case through the wire or conductor, then that is the case of current electricity. And when charge is at rest, basically when charge, some charge, let's say one coulomb or two coulomb, we'll get to know what is coulomb and something like that. It's a unit. Like we have metal that has a mass, and that also have a unit like kg or gram. Similarly there's coulomb. Okay, so static electricity is nothing but its charge at rest. Now we are going to study here the static electricity, basically about charge at rest. Okay, na? And now also well known electrostatic charge and also we can say this as the electrostatic charge. Electro means charge and static means rest. The charge which is at rest. Also we can say this the static electricity as electrostatic charges. And now furthermore, the generated due to friction. This is one of the method, as I told you. Electricity could be generated using friction or induction, and also other one we have is by conduction. So now coming to the matter is made out of atoms. So as we know, if I talk about charge, where the charge is coming from. So basically we have matter. Matter is made out of, maybe it could be from some element like let's say the sodium atom, right? Sodium atom it could be, or we can say made up of matter is of magnesium, or maybe it could be from made of iron element. So iron, if there is an element, the matter is made of iron means we have the atom of iron, right? We have atom of iron, and atom is made up of, as you know, that there is a nucleus. Atom have nucleus where proton plus neutron are there, and the electron is revolving surround this. Okay, electrons are surrounding. So in a neutral matter, means proton, number of proton will be equal to number of electron, right? In neutral case, so we have atom. Let's say this is the nucleus. We have neutron. This is neutron and positive charge particle that is our proton. So this is our nucleus, and electrons are revolving around this, and these are binded with nuclear force, or we can say kind of a force which is bounded. That is nuclear force, I would say that. And the electrons are revolving in a definite path by according to some scientists, right? And these electrons can be out of their cell. We can say it as like coming to the excited state, because this is ground state, this one is ground, and second one we have can call it as excited. And when some electrons is coming from this side, this point, to coming from the, and we isolate it, then we can say that the ionization energy is required, and that case the electron is out of the range from the atom at nuclear force. So then that case the free electron will be generated, right? Free electron means we will get to know this free electron. This is basically contribute for the charge. So the electrons is negatively charged and proton is positively charged and neutron has no charge. Okay, here there is a nucleus and electrons are revolving like this. So electron is negative charge, and when a matter will be negative charge, let's say when number of electron on this matter, number of electron in this matter will be higher than proton, then the matter could be of negative charge, or we can say the excess of electron there will be. And some case maybe electron is less than proton, means some electron is get deficiency, there will be deficiency of electron. So this matter could be of positive charge, and when number of electron is same as number of proton, that is the case of neutral condition. Now coming to our where do charge come from, as I told you how charge is coming. Basically there is a excess of electron or there will be deficiency of electron. In only two cases the charge will be there on a matter. So if the electron number of electron is same as number of proton, that is neutral, and the electron is greater than proton, the gaining electron means negative charge the body have, and similarly this is the positive charge as I told. Now coming to how do charge behave, means if we have a two charge, let's say two positive charge are there, then how they will behave. If we are taking close to each other, then both charge repel each other and moving this charge in outward from their center, means two like charge. If you have a two like charge, means similar kind of charge, either it is two positive or two negative, that will be repel always each other. And if we have unlike charge, that means one positive one negative, that will attract one another. Like unlike charge will attract. We have to remember these things. And the charge object may even attract neutral one. Means if we have a charge, let's say a body, a sphere, it is a neutral, means number of proton is equal to number of electron. But if a charged body, let's say this is a positive charge, is close to this sphere, which is a neutral body, then there will be induction of charge, maybe this side negative due to electric field, we'll get to know about that also, and this side will be positive. So in that case we can say that the charge, this by the induction, by this charge they will be attract this negative charge, and this charge this will be repelled. So a neutral body can also be attracted by a charged body. No need to attract or repel only for the to charge or to charge or this like kind of charge. Now coming to the examples, so let's say when a polythene rod, we have a polythene rod, is rubbed with a woolen cloth. Let's say we have a woolen cloth, right? And the electron transfer from the wool to the polythene, means this woolen cloth, this is woolen cloth our, and this is our polythene rod. So the electron is transferred from where? The electron transfer from the wool to the polythene. This wool to the polythene means there will be excess of electron. This will be excess of electrons. That means, and this will be deficiency of electron. Deficiency of electron. In this case, we can say that this rod will have negative charge and this will have a positive charge. Now, we have the kind of matter that we have is like conductor, insulator, and semiconductor. So we basically classified matter into the three categories. Now let's see the properties of these by one. We have a conductor here. We have insulator and semiconductor. as we already know in the class of 8. So they are material that allow heat and electrons to pass through it. Basically, this is the property of conductor, and they don't allow heat and electrons pass through it. That is the property of insulator, just opposite of that. And semiconductor is basically just a poor conductor, whether cold or but in much better conductor when warm. When if you have a matter of semiconductor, then if you warm it, then that will be better conductor because free electron will be more available. That's why. And now coming to our second, like electrons are loosely held. Here electrons easily escaped from their cells. That's why electrons are loosely bound. Means the effect of electron with nucleus is loosely bound. That's why. But in case of electrons are tightly packed insulator. In insulator, electrons are tightly packed. But in case of the semiconductor, this is between conductor and insulator. Now, now let's say take the example of each. You can take the example like we have metal. Is a conductor and plastic wood is insulator. Basically, electrons are closely packed. But in case of semiconductor like silicon and we have germanium and arsenide as well, and many or these are the electrons are basically in between them. Now we have earthing. So let's understand the earthing. If charges build upon material, charges built upon a material, the electrons may pulled through air and cause spark. Means if you are pass through charge upon a material, let's say one wire is there and another wire we have is there, right? And the electron is passed through this wire to this wire by their conduction method, or we can say any kind. But so basically, what happens? So there will be production of a spark due to the electron may be cooled through the air or cause spark. As we in the electricity, when there is an electricity wire, electricity is flowing in your household, and we just wanted to touch with another maybe neutral wire, then there will be a spark production between them. Is that only the case? So basically, in household, when live wire or where the current is following, we touch with our like earth, maybe or any neutral wire, then there will be also production of spark. Basically, there will be electron flow or pool, we can say. To prevent any danger due to this spark, the object can be earthed. Means any object or any our equipment like we have so many equipments of electricity there in our household. Like we have washing machine, we have like laptop. So these equipments can be earthed, but sometimes you have seen one extra wire in your electricity board that is earthed already. So we need not to earthen this device. But if you do that, that will be your extra protection. That's it. Now we coming to the electrostatic induction. So let's understand before and already know the friction also charge can transfer, and also by the electrostatic induction we can also transfer the charge. Let's say the different kind of method we have here, like in different situation, charging a two-sphere system using negatively charged object. Let's have we have two system A and B, and this is insulated, right? This rod is insulated. Now, a negatively charged. This negatively charged is close to this sphere, and these are touch with each other. There will be production of this side positive charge, and this side will be negative charge. And now, if you want to make this charge what is positive, then just separate it, and this will be of negative, and this will be of positive charge. And now, I just wanted to make independently the positive or negative charge. So, what you have to do, just you have to see in this fourth picture, what you have to do. Can you imagine that? How can we do that? This thing, like in fourth picture, just separate, just isolate this both, and we'll get the positive charge and negative charge. The excess charge distribute itself because excess charge will distribute itself throughout the sphere. We can see. So these are the process you can make at the same time to one positive and one negative charge by this way. Now, Second, we have by induction method using our positively charged object. Okay, so we have already two same sphere. These are sphere touch with each other. That is conducting sphere, but this is insulating rod. Now a positive charge is brought up, and there will be induction of negative charge, and there this side will be positive charge. Why? Because of the electron is moving from this to this side, this sphere, and now just separate it. This sphere will be wholly positive and this sphere will be wholly negative. Now just we remove this sphere and get there the independent positive and negative charge. Now we have charging a single sphere by conduction. Now this is the case of single sphere. Let's say this was the single. So what happened in this case? There will be a positive this side and there will be on the further side there will be negative because of this positive charge. Because of this negative charge, there will be negative charge brought close to this. And now you have to earthen this side. We have to earthen this side so that the electrode can be transferred to earth, and that's why we can just have a positive charge on this side. Okay, and just brought away, and you can take this away, and that will be a positively charged sphere. Now coming to the second sphere by induction, and here we using charging a single sphere by induction. So basically here I just wanted to create negative charge. So first you have to take a positive charge body, and this is close to this, and this side negative charge will be there. And what you have to do, similarly you have to earth it, and by earthing the earth electron will be going to sphere, and this positive charge will be neutralized, and this side only have negative charge, and at the last we will get the negative charge body will be there, and just separate out this positive charge, the system will be of negatively charged. Now we have electrostatic. We have electrostatic here induction as we move the production of charge in an uncharged body by bringing a charged object close to it is known as electrostatic. So as we have seen four technique, four examples of charging here in the picture, and this is only the definition you can write for the induction of electrostatic charge. Now coming to the our this effect of charge, that is electric field. So basically if we have a positive charge, like say, and there will be the emergence of electric field line in that way radially outward if we have a sphere of positive charge, and in case of we have a negatively charged sphere, then electric field line is coming from infinite and terminated on it. And these are the electric field lines. And let's understand what is electric field basically. So coming to our, and in case of we have positive and negative charge with same quantity, or maybe it could be of different magnitude. In this case, the positive charge line, electric field line will be terminated on negative. Can you see that? Now coming to our electric field definition. So here we can see basically electric field. What is that? The region around the electric charges where another charge with placed will experience a force of attraction or repulsion between the electric wall and electric field. So basically, if you have a capital Q charge here, a small q charge is coming here, let's say at a distance d, right? Then due to this charge, let's say this is positive charge and this is negative charge, because of this charge this produces the electric field in this region, and this will experience a force due to this charge, and that region up to that region where this force this charge is facing the force, that is called the as the electric field. Now the direction of electric field is from the positive charge to the negative charge. Okay, and the electric field is represented by imaginary line, that is called as electric field lines. Now this is your homework. So basically write any three dangers of static electricity. You have to write three dangers. What can they affect, right? So yeah, in this lecture, that's it. We will get to know many more things in the further lectures. Hope you understand everything. And if you have any query, you can let me know. So okay, bye bye.